All right, so we left off on slide 17. We had just talked about the Gus and Mouse class. Hopefully some of you remember that. The large audience of you remember that. All right, the next section here is about reference variables and instantiation. Okay, we pretty much so far have been using primitives. We've been using integers and longs and shorts and floats and...
Before you really get
Yes.
going, how are we supposed to put our school ID number for username and our
It'll be your first initial, last name, school ID.
That's the problem.
Yes, that could be the problem.
Thank you.
No problem.
Sorry to
Okay,
interrupt.
so no problem. So reference variables is declare. First of all, what the heck is a reference variable? Okay. First of all, anything that's not primitive is normally reference. That's an easy way to think about it. Okay. Anything that's not built in, well, some of them are, but like we went through the example of the mouse. The mouse is a class we built. Then we declared instances of the mouse. We declared Jacques and Gus. So those would be reference variables. So it's declare a reference variable which holds the address of memory where the object is stored. I don't think this goes into that. So let's talk about how they're stored first of all. Variables. If I store an integer, okay, maybe I'm going to make an integer. Think of it like an Excel spreadsheet. I say I'm declaring an integer, and it's stored right here, and it's on cell A5. Oh, big deal, it's right there. So in memory, if my memory is an Excel spreadsheet, cell A5 now has the value for my integer. That's how a primitive works, not an issue. With a reference variable, what happens is, so I'm going to create my mouse, I'm going to declare Gus like we did, like right here. Here's Gus, the example of Gus. In that same spreadsheet, now in A6, I don't put Gus, but what I do put is I put a reference to where Gus is going to be stored. Because Gus is an object. It's not just like an integer that's one thing. Gus, if you remember, let's look at what we did on our program. What did we have for Gus? We had age and weight and percentage growth. So Gus had different components to him. So when we declare him, our cell spreadsheet on A6 now doesn't contain all that stuff. It just has an address that says, oh, Gus is stored over there. And it points to another location. So the reference variables, the way you declare them, the class name like mouse, and the variable like Gus. Okay? And it basically holds the address of where it's going to be stored. Okay? You okay with that? It's kind of like you got something that won't fit in the cabinet, but you still want to put an entry in the cabinet. Say, oh, this is located over on such and such a place. And speaking of that, everyone ever watched TED videos? TED, you ever heard of TED?
Yeah. TED TV.
Yeah, TED TV. Man, there was a great video we watched yesterday about robotics. They have this TED TV. It looked kind of like a warehouse for Office Depot or Staples or something like that. They have it set up where the people packing them never move. The robots go out and bring the entire shelves to them with the components. So you stand there and you grab this, scan it, put it in the box. And the shelf moves. And the next shelf that you need appears, you grab the item and put it. It was like,
So the robots were using us for questions.
right. The robots
so
are out
weird.
are bringing the shelves to the people. So instead of me running around the warehouse looking for stuff and filling a box, the warehouse is coming to me. Now I just take it. If you ever say it's a TED Talk on, I don't know, search for robotic shelving or robotic warehouse. It was really, really interesting. But it was, I was like, you gotta be
Some of the
kidding.
topics they cover just absolutely.
Yeah, and it's like, who thought of that?
That is crazy.
And it goes by, because what happens is if I pack really fast, the robots come to me faster. And the stuff that's frequently used is stored near me. Other stuff is stored farther away. And it's like, for the people, they just stand there, grab it from here, and put it in a box. It's like, wow. So now they're getting no exercise. All right, but with reference variables, again, we store a pointer basically. It's really a reference to the address where it's stored at. Okay? Then once we do that, so the first part here, we're declaring it. Then to instantiate or create it, kind of like when we did int number. We said we are going to be using a variable called number that's going to hold an integer. Haven't given it a value yet, but we're going to. That would be the declaration. Then to instantiate it, we'd say is equal to 52. Well, with reference variables, when we say Gus equals new mouse, well, now we know Gus is going to be stored over. Now he's actually stored over there. Now we're actually going out and we're building it. Okay. Here's our example. Mouse Gus. Gus equals new mouse. Easy enough. All right. Says the single line can be done as well. Mouse Gus is equal to new mouse. That's how it's normally done, but you can do it either way. All right. Now calling them. To call them, you have to specify the instance of the object. So it says after instantiating an object, you assign an address, a call to invoke it, you use reference.method. So at the bottom we have the example, gus.grow, gus.display. Gus was the instance of the mouse class, and then the display and grow are the methods. Okay. Here's an example. Okay, we can have arguments there as well, like the set percentage of growth did. Okay. All right. The calling object is the object that appears to the left. That will be the Gus, or the Jacques, or the Mickey, like we made yesterday or Monday, whenever we did this. Okay. So the calling object is the object that appears to the left of the dot. Can we find them? Yes. Gus is three. Yeah, we declaring them there in the middle, but we're actually using them down at the bottom with gus.set percentage growth rate, gus.grow, and gus.display. So the object, the colon object, is Gus in this case. Easy enough, hopefully. Okay? All right. Let's talk about this. We actually talked about this somewhat last time. It says this is when used in conjunction with a dot and an instance variable, this is referred to this reference. Note the example. We did that. This dot wait. Okay? If you always use this, you'll be safe. But there's sometimes, like I showed you last time, where you don't need to use this. So it's one of those deals, kind of like with an if statement or a for loop. Remember how I said, if you put the squiggly braces there, you're great. But if you don't want to put it in there, you can, as long as you're only doing one line. But so this, if you always put it there, you're going to be safe. It says that this reference is used inside of a method to refer to the object that called it. In other words, it's referring to the calling object. Okay. Which we'll see some examples here in a second. What's great about having a special name for it, why not just use the original name when you really can't? Okay? It says because if the original name was being used, then the method would only work for one specifying object, but with this it works for everything. Like so, we probably have an example here. No, we don't. Let's go back. Let's look at an example. Go back. Where's our example? There it is. Here's our example. This dot wage, this dot age, or using this dot percentage of growth rate. Since, remember we were making instances of this mouse class with Jacques, Gus, and Mickey in my example. If we had, instead of this, if we had put Jacques dot percentage growth rate, it would only refer to one. But by saying this, it refers to each of them. Saying whichever one happens to be calling it at the time. Okay? All right. So if you always use it, you're going to be safe. It won't be an issue. We'll see more examples of that. All right. Now default values. Says the variable default value is the values that the variable has if it's not being explicitly initialized. In other words, if we don't declare it or give it initialized value, say we declare something but don't give it a value, it gets the default value. Okay? So here we have private int age equals 0. We're giving it a value. I could have said private int age equals 5. I could have done whatever. We are initializing it to a value. Okay? In weight, we gave it 1.0. Okay? Now, percentage of growth rate, we did not give it a value. So it gets the default value, which happens to be 0. It's kind of important you realize this because it saves you time, actually. Okay? So percentage of growth rate, if you wanted it to start out as being 0, you really don't have to give it 0 because it's going to automatically get 0. Okay? Look at the bottom. So integers get 0, floating points get 0.0, booleans get false. So Boolean values, the moment you declare them, they automatically have the false value. So you can really save time where you don't have to set them to false because they're already false. Is it a good idea to do that?
Well, I mean, if you understand.
Right. As long as you totally understand it, you're fine. But remember, other people might be coming behind you because like 75% of the work done on programming is not creating the program. It's maintaining the program. I mean, even okay, I have an Apple phone, Apple iPhone. Okay, I buy an app or I download an app. I'm always getting updates to these apps. Obviously, people are finding problems with them or fixing them. Okay, you know, I got a 2012 volt. I was reading about the other day. Someone had 2011 volts. It's like 240 updates applied when he went to the dealer the other day. So 1 year, that car had 240 updates. It's like crazy. Okay, so there's lots and lots of things fixed. Okay, you know, I had a house built. Anyone ever built a house in here? Have a house built? I don't know if I'll do it again. It's tough because you got to be in charge of everything. You got to, you know, make all these decisions where if you just buy a house pre-made, you know what, all the decisions are made for you. A lot of times it's like, you know, just do it. You know what I mean? Just do it. Don't ask me, just do it. But I did like the capability of doing that, you know, but, you know. So if I'm 100% positive, you know, I'm writing this program, I thoroughly understand it, whoever comes after me is going to understand it, no big deal, leave it alone. But if you want to be safe, give it a value. Okay? So Boolean gets false, reference variables get null. What we mean by that, if we said mouse Gus, just mouse Gus, no mouse Gus equals anything, just mouse Gus, it basically gets a null value. It says, you're going to be creating a mouse called Gus. So in my cell E6, it doesn't know where to point to yet because we haven't created the mouse yet. We have E6 or A6. We have that block. It's going to hold the location of our mouse, but we haven't told it where it's at yet. It's kind of like Ken Dewey's going to buy a house. Okay, great. They know Ken Dewey's going to buy a house. Maybe the realtors got me ready. They got me on the books to sell me a house. Do they actually have where I'm going to move to yet? No. All they know is I'm going to be buying a house. So it gets a null value because it doesn't know where the location is. Okay? All right, it says note that a string is a reference type, so it gets null by default. Strings, if you play with C++ a lot, I'm assuming Mike has, strings are different. They are different. And Java kind of makes it easy for us. It automatically does a lot of stuff with them. But really, they're still a reference type, even though we can just declare them as normal stuff. Okay. All right. Variable persistent is also very important. Okay. Variable persistent is how long it stays there before it's wiped out. This does vary by language, because Java has something cool. I don't know if they mentioned here in the chapter. They have something called the garbage collection service, which goes out at the end of each method, totally wipes out everything, clears out all memory, and you're good to go. C++, on the other hand, could care less. C++ is kind of like, all right, I'm selling you guys my house. I move out. Whatever's left behind is yours. You could have furniture, trash. Where with Java, when I move out of my house, if I was Java, I'd be cleaning the cabinets. I'd clear everything out. It'd be empty. So it's really different depending on the language you use.
Doesn't that create problems in the way of C++?
Oh yeah, it definitely creates
You
problems.
have to clear, like run a command saying clear all this crap out.
Well, a lot of times if you don't clear it out, it'll just maintain whatever happened to be in that memory location before. So that can cause errors. So yeah, you know, C++ is an awesome language. It's probably the most powerful language out there. Well, I guess assembly would be more powerful, but it's just that it's got so much flexibility. With C++, you can create an array, which we haven't covered yet, but you can create an array to hold 10 items. You can put 300 in it. It just overwrites what's in memory. No problem. So it takes the first 10 and just keeps on going. So Java, on the other hand, if you create an array to hold 10, guess how many it holds? 10. That's it. Try to put 11, it's like, whoa. C++ could care less. You could just keep on writing until your heart's content, overwriting whatever's in memory after it. So get different variables, do it differently. All right, so persistence is how long they store there. They stay. Okay. Instance variables persist for the duration of the object. Thus, if an object takes 2 method calls, the second call does not reset its value. Okay. Instead, the object instance variable retains the value from one call to the next, which we'll see an example of. Okay. No, we won't. Not yet. Okay. Here's tracing. Okay. We talked about tracing, I think, in chapter 3. We walked through a program. But when you do this one, you know, provide the setup, start. Let's just look at it real fast. Okay. Wow, a lot of pages for that. Okay, they're going to walk us through this. That program we wrote earlier. Okay, so we're going to walk through this thing here. Actually, let's look at this one here. Let's see the error he's talking about. Up near the top here, right up at the top here, we declare Gus and Jacques. We basically say we will be having mice, one called Jacques, one called Gus. Okay, so we have the memory. We have cells A8 and A9. No data in them yet. They're both null at this point because we don't know where they are, but we have those initial blocks ready to hold them. Then down here, we're saying Gus equals new mouse. So Gus, whatever, A8, which is Gus, is now pointing to a location wherever this new mouse has just been built or born or whatever. Jacques, on the other hand, you'll notice we didn't do that. Okay? See, Gus is a new mouse. Jacques, wait, Jacques is a new mouse.
No, it didn't initialize the growth rate.
They actually initialized the growth rate. Oh, I thought they forgot to initialize it. I said, we did that? Okay. Yeah, you see here they did not initialize the growth rate. They did for Gus, but not for Jacques. Okay. Yeah, so I thought they forgot to initialize the whole mouse. I'm like, it's right there. So, yeah. So, actually, no, let's look at that. Let me go to our program we made. We made mouse, and we made mouse driver. Okay. Let's go into ours. Let's simulate this. Let's find Jacques. Okay, we're getting rid of his growth rate. Okay, so I'm going to run this. Okay, growth rate percentage will be 2. Huh, still worked. How did it work? Well, let's see what happens here, okay? So Jacques is a new mouse right here, okay? I did not set this. Actually, let's change this for a second. I'm going to go in here and give it a value equals 5.0. Okay? I'll just say 5. Well, 5.0, okay? I'm just doing that so we can see the difference. Actually, it's still going to do it. Yeah, it's still going to do it. I'm trying to think of an example how I can do this. How can I...
change the growth rate on the 2 mice and not Jacques?
Yeah... something... Actually... Okay, yeah, well, let's do that. Okay, let me go back to where that was. 5.0. Let's compile this one. I'm trying to get this to work. So we're not declaring Jacques, but we're going to declare everybody else. Okay. Now I want to make sure everything's exactly the same. So Gus, we have a growth rate. Jacques, we do not. And we want them each to grow once. There. Now they're the same, aren't they? Except they have no growth rate for Jacques. Okay.
Mickey's growing.
Is he? No. Yeah, Mickey is. That's fine. So I put in a growth rate of 2. You notice how Jacques and Gus are not the same. See that? Even though they should be. Because right here they both grow once. Both declared above. What happened was on Gus right here I set the percentage of growth rate of the 2 that I entered. Actually, let me make them grow really fast. We'll say 2,000%. See, so Gus is very heavy where Jacques is not. Why is Just not heavy? Why is Jacques not as heavy? Because he did not get that 2,000%. What he got was this value right here, which was the default value. Now let's take the 5 out. Now let's do it again. Do 2,000. See? So really Jacques is not growing because he has no growth rate. So I could have him in there 100 days. He's never going to grow. Let's do that now. Let's make Jacques grow a couple times. he'll gain in years, or days, I guess it is, but see how his age is going up, but his weight's not going up? Because he doesn't have any growth rate. His growth rate is set to 0. Whereas Gus got declared and Jock did not. Okay, kind of understand that? It's kind of weird, but it's just, do you understand, Terry?
I understand you.
Okay. Yeah, because we set Gus's, we just didn't set Jock's at all. All right. To trace through it, you just walk through each line, and you know, it takes time to do this. I'd rather not, but you go up here, and when you're initially made, you just, you know, set values just like we did in the other stuff. Okay. I'd just rather not walk through it all because it would take a while, as you can tell. When you first declare the values, you know, they got question marks, but I'm not going to require you to do it. But this stuff does come in handy, especially when you're trying to find errors in your programs, like the program you all had to do about the driving distance. So many people turn in programs with errors in it. I'm like, did you actually do the math and see what you should have gotten, and did you get the correct value? So many times people don't do it; they don't get the correct value, and they're like, "Oh, I didn't know that." I'm like, "Did you not test it?" I mean, that one at least I gave you some values that would work. But yeah, all right. So tracing is kind of important. Now UML. All right. Now this is for the next. This is the new improved mouse. This is going to be mouse 2. Okay. So our driver has a main method. Okay. Inside our main method, we're going to have we're going to instantiate a scanner, we're going to instantiate mouse 2, and days, which is type integer. So Mickey is going to be mouse 2 now, and he's using my name. Jeez. All right. So the mouse 2 class itself, we have age, which is an integer. We're going to set it to 0. Does anyone know what that? Oh, they show it at the bottom of the screen. Okay. The minus and the plus. Y'all see the minus and the plus there on the left side? The minus basically says we're going to set it private. The plus means public. Okay. So inside of mouse 2, at the very top, we're going to have int age equals 0. Double weight equals 1.0, and double percentage of growth rate. Again, we're not assigning that one a value. Okay. All right, then we have some methods, some public methods. All right, now the first one there, set percentage of growth rate, is going to take an argument called percentage of growth rate. It's going to be a double. Then you see where it says void at the end? It means it returns nothing. Okay. Now get age is going to be public. Again, I'm looking at right down. Let me find it. Where did my mouse go? We're looking at right here. So get age is going to be public. We know that by the plus. It's going to return an integer. Get weight is going to return a double. And grow, it's going to be void. It's not going to return anything, but it's going to take something. Okay. All right.
They're not going to return anything?
Grow will not return anything.
Or growth rate?
Right. They do something. See, you have normally an accessor or mutator methods. Okay. I haven't covered that yet. But grow, it's kind of like I tell you to grow, so the mouse grows. But you don't need to come back and tell me anything. With get age, that's where I say, hey, how old are you? I want you to tell me something. It's kind of like me telling you to do something. Okay?
You just go do it.
You just go do it. If I say, go do it and bring me back something, go to Brahms and bring me a milkshake, that would be different. Now, if I just say go to Brahms, you're going to go to Brahms, you can eat lunch, whatever you want to do, you don't have to bring me back anything. Go to Brahms and bring me back something, and then you would have a return value on it.
That's what void is.
Exactly. Void means, okay, go eat lunch. Don't bring me anything. I'm good today. I happened to win the Brahms yesterday, if you didn't guess. Had some
Brahms is awesome.
What
chocolate.
variable type would that milkshake be?
That would be called fat. Now, I had a chocolate peanut butter yogurt. And I just happened to see it over Christmas break, and I'm like,
Have you ever had chocolate peanut butter? It's just amazing.
I know. But I saw the yogurt. I said, you know, yogurt's a little, okay, not much healthier, okay?
Right.
But a hair. I mean, if you're going to eat crap, this is crap that's not quite as bad. So I tried the yogurt. It was like, oh my God, that was the most amazing ice cream ever.
Yeah.
So, did all you can eat ribs at Rib Crib yesterday, so the guy's going to listen to this message because he works there. And then drove by bronze, picked up ice cream. So it was scary. All right. Yeah, the return type would be fat on that one. Returned yogurt, I guess. But all right, so let's continue on. All right. So let's talk about local variables. It says local variables that declared inside a method. It says that's different from an instance variable that is declared at the top of a class. So if I have a method and I declare something inside of it, it's local to that method. Okay? Its lifespan is that method. Declare it in that method, and it can never leave that method. Okay? So the difference between an instance variable, which is declared at the top, and works with all methods in the class, or we'll see. Okay, if a local variable is called local because it can be used only inside the method in which it has been declared, it is completely local to that method. It can never be used after it. Now try playing with Pascal someday. Pascal 286, I actually wrote code for the military in that. Oh, before you could use anything, you had to declare it first. So it basically had, even your methods had to be declared before you could use them. So if one method called another method, well, the methods that it called had to be declared above the one that used it because it was hard. It was really Java. You're not quite that bad. So. All right. So in mouse 2 in the next slide, note our main method has 3 local variables, and it says mouse 2 class. Now the grow method has 1 local variable. All right. Now. Let me go copy this one real quick. This is 34, so we can talk about it. Okay. Now let's get a copy of mouse 2 right here. It's going to take me a minute to copy it. Sorry about that. This is going to be on, I think, 2 slides, maybe 3. Come on. Okay, now we need the next one. Yep, there's the last slide. Should be on 3 slides. Okay, there's the end of clap mouse 2. Okay, I'm going to save this one. I'm going to call it mouse 2. Nice and pretty now. Look at that. Now let's get the driver. Oh, we didn't. Okay, we don't need the driver yet. Okay. Let's go talk about this program first. All right, so mouse 2. So, wait a minute. Oh, this is the driver for. Oh, did I have both of them? Oh, I did have both of them. Well, heck, hold on. They are both there. Mouse 2 driver. Sorry about that. So I need to delete all this.
Put 2 in the same one? Or?
Yeah, I put both of them in the same one.
I thought you might have, but I wasn't sure.
So this is the driver. So mouse 2. Let's remove the driver from the mouse. There we go. All right. So they are there. All right. First of all, let's run it and see what it does. Okay. All right, we're going to run it, compile, run. Number of days to grow. We want to grow at 5 days. All right. Wow. At day 5, the weight is 1.611. Let's make it grow 300 days. Wow. That is one big ass mouse.
Big damn mouse.
Yeah, that is. Woo. It's a Mondo mouse. All right. So let's talk about the mouse class itself first. All right. So now we have our variables here at the top. Let's actually compare to the original one. Here was the original one. Remember, we have age, weight, percentage of growth rate. They were private and double. Okay. Mouse 2 is same way. Really no difference here. Okay. Top's pretty much the same. Set percentage of growth rate is the same. But now we have some new stuff. We have get age. This is called an accessor method. Okay. When I have you guys write programs, I'll say things like, make sure you have the correct accessor and mutator methods. Accessor, what's the word access? What does that mean? You access something. I'm going to access the whatever. So an access, you want to access the value. So I'm going to access the age and return it. So an accessor normally returns something. Okay? Like I accessed that ice cream last night. All right, so an accessor method returns something. A mutator method changes something. Okay, so here we are getting the age, and we're getting the weight. So they both return something. Okay, I would probably put a little bit of comments in here. Again, I realize get age is pretty self-explanatory, but add a sentence right here that says, you know, just the whole point of comments in this class, by the way, just so I know that you know what it's doing. Sometimes people don't realize. I don't know what it does, like that girl I was telling you about. Her boyfriend wrote it. Oh, that's bad. Alright, so get age obviously returns age. Get weight returns the weight. Pretty easy stuff there. Now grow. Grow doesn't return anything. So this would be more of a mutator method. It's doing something. Okay? So grow receives days as an integer. Okay? So it's receiving days. Then it has a for loop. Okay? It says for int or I equals 0. I is less than days, I plus plus. So we're declaring I is 0. Going to continue as long as the number of days. Because if I put in 5 or 300, that's how many times this loop's going to go. Then it's going to increment after each time. And what it does is this dot weight is equal to 0.01 times the growth rate times the weight. That's how come that mouse got really heavy. Then age is equal to this dot age plus equals days. So what happened? Did this mouse gradually increase age day by day? No. He just, whatever he was, he's now that number of days older. Could I have done it a different way? Sure. I could have put that inside the loop and did age plus plus, this dot age plus plus, and it would have been fine. Could have incremented it along with its weight. Okay? But, I'm just going by the way he wrote it. So, all right. Is everybody okay with what this is doing? Now, let's look at the driver now. So we have the scanner class, as always. Do I have to call it stdin? No. That's what, but you don't have to. I could call it anything I want. So I have a new object here of type mouse2. Object is Mickey. Okay. So the calling object is Mickey. It's of type mouse2 is equal to a new mouse. Okay. So this first part basically created a cell in my Excel spreadsheet. It said, all right, Ken will be having a mouse. Put it right here in E5. And then this is, the mouse is actually over in the next building or the next sheet or spreadsheet. So E5 now points to that. It really holds the address of it. Then I have integer days. Okay. Then I said Mickey. Actually, yeah, let's talk about this. So we got Mickey, which is the object. Set percentage of growth rate 10. Okay. And the number of days to grow. And we get input for the days. Then Mickey, grow 10. So over here, when I put in 10, that 10 gets received here. And I do all my stuff here, then I'm done. Now, we talked about local variables a minute ago. There's two local variables in this method. Does anyone know what they are? Inside the grow method, there's two local variables. What do you think they are? Inside this method, there's two local variables in that method. Give you a hint. First one's on the first line. Days. Days is being defined or declared right here. It's being received as an argument, but what happens is the value of days is passed to this method. So we're receiving it into the variable called days. I could call it frogs. It doesn't matter what it's called. So the value, so days gets its initial value here, but the moment I reach the end of this method, it's gone. The garbage collection service gets rid of it. What's the other variable? I. I is declared right here, initialize 0, and watch this. I'm going to, actually before, right here, and say system, actually I'll just do this. I plus plus. We're going to increment I. Will that work right there, you think? Why not?
Because you haven't declared I as it did before you try to.
All right, I got an error down here. It says, whoa, cannot find variable I.
It doesn't know what it is.
Like, what the heck? Why can't we find I? Okay, fine. We haven't declared it yet. All right, fine. Okay, well, I'm going to put it down here. Okay, now I've declared it now. You all see I declared it. Is it going to work now? Still, hold on. It says, cannot find symbol variable I. Dude, it's right here. Didn't I declare I mean, int I.
No, it's locally, so once it hits that second bracket, it's done.
Right. Since this variable was declared inside the for loop, the lifespan of that I is right there. At the end of the bracket, the squiggly brace there, whatever, at the end of the for loop, I's gone. So is that a good thing that it does that?
Depends on your application.
Depends on your application. Different languages do it different ways as well.
You should declare it.
But it's kind of nice
Squiggly
because
braces, and that's it.
Java's point of view here is, you declared it in the loop. I'll let you use it in the loop. But then we're going to kill it. So you don't need it anymore. But if I declared it outside the loop, I could use it the whole method. So when I get down here, it's like, what the hell are you talking about?
You can also run into issues like because you have it incremented twice. If you didn't mean to, then you're trying to figure out why the hell is it incremented
Right.
twice.
So Java's saying, if you want to use it outside the loop, then declare it outside the loop. If you declare it inside the loop, it's local to the loop. Days, for instance, is declared at the top of the method. So days can be used anywhere inside the method. But outside the method, it can't be used. So days is local to the method. I is local to the loop.
This may be something I missed, but each time we're doing public void,
Right.
private int, public double every time.
Right.
That's losing it.
All right. Okay. These are methods. Grow is a mutated method. I want to do something. So this is a method I can call, and I call it right here, Mickey.grow. So I have an object, Mickey. I'm going to tell it to grow. So I need a method called grow. And get age and get weight right here, I use those right here. Get age and get weight. I want to get Mickey's age and Mickey's weight. Those are separate methods. Remember how we talked about last class period about the whole point about object-oriented is it contains data and methods. Well, the data of this mouse is its age, its weight, and its percentage of growth rate. The methods that we can perform on this mouse, we can get its age, we can get its weight, we can make it grow, all that kind of stuff. Okay. So get age is called a mutator, an accessor method. I'm sorry. We return the age. Get weight returns the weight. Whole point is you always want to do everything because let me show you something here. If I went over here, I did system.out.println, and I said Mickey.age. I want to access Mickey's age. We know that Mickey has an age. It's right there, age. And since we're calling in with the object and then the method, well, I'm going to use the object and then the variable. Well, let's try it. Got an issue. It says age has been declared private, it has private access in mouse 2. So I can't do that. Well, the way I could fix it is I could go over here and make age public. Now, in my driver, now I can do that. But is that a good thing?
Depends on the application.
Well, what if I just happen to mistype my code someday and put that in there? Okay. I'm gonna get rid of this whole print line even. I accidentally put that line in there. Okay. So I'm gonna run my code. Number of days to grow 5. Whoa. I said grow 5 days. This dude is 47 years old. How did that happen?
You declared it. You gave it a value.
Right, because I told it to grow. Now I should be passing it the number of days to grow in the grow method. But somebody else accidentally went in and gave age a different value. That's kind of like someone going into your checking account and say, oh, take $5 away from Ken every month without anyone knowing. When something's public, it can be changed from anywhere. Anybody who knows about it can change it. Not a good thing. So if I go back over to mouse and change this back to private, now it can only be changed from inside this method. So down here we can change it. So now I go back to compile my driver. It's like, whoa, 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 there's private access. So this Mickey equals 47 no longer works. So it prevents people from screwing with it. Kind of see that? Okay. So it prevents me from doing that. Could I still screw with it? Sure I could. I could go over in mouse 2 here and say this age equals 47. And when I run in now, he's 5. Whoa, he's 47 again. How the heck did that happen? So I could still screw it up. But the whole point of encapsulation is, I don't want people to screw with this mouse. People can make instance of it and use my mouse. But think of it kind of like this. I'm going to write this mouse2.java file, and it's going to be perfect. I'm going to sell it. I'm going to sell access to it. I'm not going to sell the file. Okay? If you want to use my mouse class, you need to use it correctly. So now this over here, you can access it. You can use it. It's kind of like websites. So many websites nowadays you can access. Like a prime example is FedEx and UPS. You can actually write web apps for them where you can check shipping status of products. Anyone ever order anything online? You go and check the status of it. But I can order it on Amazon and it can show me the shipping status from FedEx. How is that possible? Because FedEx told Amazon, okay, if you want to access the shipping method, here's how you do it. They gave them the web app access, basically the API for it, and said, here's how you access it. So now Amazon can query FedEx. Is that good? Did they do that?
Yep.
Heck yeah. Now me as a user, I don't have to say, okay, what's my order from Amazon? My order is whatever. Okay, now I'm going to have to go to FedEx and look it up. No, I don't have to get the tracking number and go to FedEx. I can just go into Amazon and do it all in one place. It makes it more convenient for me. So this mouse driver here, anybody can write a driver now. I actually, in my advanced class, I give them a file like the mouse2 file. It's obviously not the mouse file, but I give them a file and I tell the students they have to access it. They have to write the driver to access the file. So I just tell them, here's how to do it. You have to figure out how to do it. So what it is, I tell them, here's what I'm going to provide, and then you can just utilize it. So it's very, very, very nice. Okay? Kind of got the idea how this is working now? The only thing we didn't talk about is this printf down here. Same one as last time. We have the format specifier of D. What's D for? Anybody? Dummy? Dewey? I'd say dipshit, but that'd be a bad word.
That's what I was
Decimal integer, remember that? Decimal integer, yes. How about this F? Freak? By Terry, furry? Floating point. Remember, this is going to be 0.3, so it's got 3 decimal places. So let's run it and look again. So now he's 400 years old. He is one big fat mouse. I think mice only live, no more than a year. Is that right? I don't remember that. They have a short lifespan. All right. Kind of understand how we're doing on this? All right. So we talked about that. There's our local variables. And there's a local variable there. Also, days is a local variable, even though he didn't tell us that, but it is. So he's kind of misleading there. Okay. All right. Local variable default values. All right. So default value for a local variable is garbage.
Temporary.
Okay. Garbage means that the variable's value is unknown. It's whatever just happens to be there. So that's not a good thing. Okay. So it just happens to be whatever's there when time is created. Doing this, you put a question mark there. If a program attempts to access a variable that contains garbage, the compiler generates an error. What happens if you remove 0? Let's do that. Let's go over here. We're going to go to this, and we're going to remove this. Oh, got a warning. Variable I might not have been initialized. I don't know if I can run. No, well, I don't think it's going to work. No, it's not going to like it. It's like, hey, dummy, you didn't initialize I. And you notice how even though I'm in the driver, it's telling you about this other error, which is in the other file. The cool thing is if I click on this, it goes right to that file. Okay, I put that variable there. Oh, it's happy now. All right. So if the program accesses a variable that contains garbage, the compiler generates an error. For example, what happens if I remove it? Well, we get an error. Okay, variable I might not have been initialized. Okay. All right, local persistence. Local variables persist only for the duration. In a for loop, they only persist until the end of the for loop, which we saw. Easy enough there. Okay. Return statements. Okay. Return statements allow you to return something. So int get age, you return the age. Double get weight returns the weight, so on and so forth. We looked at that already. We talked about both of these. So Mickey.getAge, we return the age to that, then it outputs it on the screen. Easy enough. Okay. Void. Okay. Void means return nothing. Okay. That's what we normally see for mutator methods, stuff like that. Okay. So grow doesn't return it. It can do stuff. It's kind of like I tell you to go to bronze. I didn't say bring me home or anything. I just said go there. Okay. So that'll be a void. Okay. Empty return statements. You can do that. It's legal. Let's look at one. So I could go over here to my mouse, and I could go to my void method. I could put a blank return statement. Why would I ever want to do that? Let's make sure it works first. 300-year-old mouse. Still works fine. So why would I ever want to do that? Well, it says the empty return statement does what you expected. It tells it to return what it was going to do anyway. It just doesn't return anything. The reason is some languages, you always need a return. So if you get in the habit of returning inside of every method, then you're safe. It's one of those things, you know, if you always get used to doing it, you're not going to have an issue. Okay?
But in Java, it's not relevant? Or?
Well, at the end of a method, a void method, it just returns anyway. It's kind of like saying if class ends at 8:20 and I get up and leave, do I really need to tell you to leave? No, but I could.
Right.
So you know at 8:20 class is over, you leave. But if I happen to just leave without telling you, well, you're going to leave anyway. Okay? All right. But we can also use it to jump out of something. Okay? Let's do that. All right. I'm going to go over here to my grow method. I'm going to do just what he did. If days is greater than 365, return. Okay, let's see what happens. Okay, 5. Worked like a champ. 100 day. Oops, that's a 0. 100. Worked like a champ. 350. Works like a champ. 400. What happened? Skipped it. It basically got to my loop, and my loop said, if age is greater than 365, just return. Don't even bother. It's like, you know, I could have output a statement like, hey, dummy, mice can't live over a year.
Right.
that kind of stuff. So that would be something good. I could.
So the idea, if let's say you wanted to put a profanity filter on like the password program, and you could put in like the swear words. And if it can
Right, you're checking it. If there's a swear word, say, please make your password better.
Okay.
Hey, dummy. Okay, so let's run this again. Oh, can't run that one. I got to run the other program. 300-year-old mouse works like a champ. 400-year-old mouse. Hey, dummy. So basically, what I could do to even make it better, well, nah, I'll just leave that one. So, yeah, so you can tell it to return. It basically causes it to jump out of that loop. So you can return kind of in the middle of a method
If it
there.
exceeds what you set it to, then it just...
Yeah. Yep. All right. So suppose you like the amount to grow only up through the mouse's adolescence. Grow method is by stopping a mouse's growth after 100 days. So when he reaches 100 days, he's kicked out of the house. Oh, you're 12 years old. Go home. Go out and get a job. Kind of stuff. All right. It says code that uses an empty return statement can always be replaced with code that does not use an empty return statement. We could say if age is greater than 100, then ending age is 100. So we basically could say, you know, you might be thinking it's going to be 200, but it's only 100. It's kind of like a maximum. Okay? All right. Software engineering observation. It says real-world programmers are often asked to maintain or fix programs. Blah, blah, blah. Sometimes find themselves having to examine the loops, reading specifically the loop termination. Therefore, it's important that loop termination conditions are clear. Normally, loop terminations appear, but they don't recommend using return statements inside of loops. It's not a good idea. The problem with the return statement in the middle of the loop, it's going to go out no matter what. So it says, for example, the grow method return statement is hidden inside of it. Don't recommend doing it. You should use restraint when considering the use of return statement inside of a loop. Yep, just what I said. All right. It works, but just not the best thing. All right. Argument passing. So what's the output of the mouse3 driver and mouse3 class? We're not going to write this one, but let's look at it. So mini is now mouse3. We give it the days of 365, so we're telling mini to grow for 365. All right, so let's go look at what the grow method does. So the grow method received 365 as an argument. Then this dot age plus equals days. So how old is mini?
365.
Mini is 365. While days is greater than 0, this dot weight equals whatever, and days minus minus, so the days are being decremented. So the grow method received 365. Y'all see that? Right up here. Y'all see that? And age is now equal to 365. So what's this one doing?
60 days down by 1.
So as long as days is greater than 0, days is being decremented. So days started off at 365. We continue until days is 0, correct? So then what prints? Whoops, I lost it. What prints on this line right here? 0 or 365? Don't answer, Mike.
At that point,
This is after the grow method. Remember, we passed days as 365. Inside of the grow method, we decrement all the way down to 0. So what do we print now?
it's
What?
going to keep running until it reaches 0, so it should be day 0.
It's very tricky. It's 365 still. Because it's the argument is passed. Okay? It's a copy of it. Because days never changed here. Remember we talked about the scope of a variable? Days is defined here, isn't it? Int days equals 365. Days in this method is different than the days inside the grow, where we passed a copy of it. We passed by value, it's called. So what we did is when we called grow right here with the 365, We passed the value 365. We said,
Pass it, you didn't.
right, we didn't hand it to you. We said, take a copy of this with me. Basically what I said is, I'm 365. Go run with it. Dude, I'm still 365. Okay? So in the grow method, it received a copy of it into days. Went all the way down to 0. Great. Go down to 0. I don't care. I'm still 365 here. Okay? It's kind of weird. Just think of it. It's passed by value. There's an opposite of that. Okay? All right. Oh, look at that. Pass by value. Okay, Java uses pass by value to pass arguments to methods. Pass by value means the JVM passes a copy of the argument, not the argument itself. Thus, the argument changes. It doesn't affect anything. Okay? Are we okay with that? All right. An argument with associated parameters often use the same name. For example, days is the same. I don't like using name days the same, just because it's confusing for people, but you can. So be aware the argument, even if it's got the same name, is really only a copy of it. Okay? Everybody kind of understand that? We're just about done, I think. How many slides are on this darn thing?
50.
Oh, yeah, we're almost done. Okay. Oh, accessor method, mutator methods. I knew they were in there somewhere. Access, again, we return something. Accessors always have returns. I'm going to return the age. Mutators, we're going to change something. So grow would be a mutator. Set percentage of growth rate would be a mutator. It's changing something. Simply sets or mutates the value. Okay, then we have Boolean methods. Boolean methods really don't do anything. Could check the status of something. Returns, whatever. So, is adolescent. It returns if they're an adolescent or not. Yes or no. Okay. Well, we're going to play more with those later. It basically just checks if something is true or not. Okay. In the example there, the method is adolescent on the left side. It says if his age is less than or equal to 100, return true because they're an adolescent, else return false. So if the mouse is greater than 100, it returns false. If mouse is 100 or less, it returns true. Easy enough? So it's just a Boolean method. All right. And that's the end of chapter 6, I think. All right.